Hey guys, this is Megan again from OnlineMathCircle AIME video tutorials, and today we are going to look at 2009 AIME 1 problem number 14. For t equal to 1, 2, 3, 4, define s sub t equal to the sum from I equals 1 to 350 of a sub I raised to the t power, where a sub I is an element of the set 1, 2, 3, 4. If s sub 1 is equal to 513 and s sub 4 is equal to 4,745, find the minimum possible value for s sub 2. So we can start off by defining a couple of variables. Let a be the number of 1s in the sums s sub t, b the number of 2s, c the number of 3s, and d be the number of 4s. We're given here that s1 is equal to 513. So that basically means that s1 is equal to a plus 2b plus 3c plus 4d equal to 513. We have a total of 350 terms in this sum. So obviously a plus b plus c plus d is equal to 350. We're also given that s sub 4 is equal to 4,745. So that means a plus 2 to the power of 4, which is 16 times b, plus 3 to the 4th, which is 81c, plus 4 to the 4th, which is 256d, equal to 4,745. So we have a system of 3 equations, but 4 variables. Now let's try to use some Gaussian elimination to get rid of some of the variables, and then maybe perhaps cut our results down to maybe one equation with 2 variables. So first, let's start off by subtracting the first equation from the second equation. This gets rid of a, and so we're left with b plus 2c plus 3d equal to 163. We can also subtract the second equation from the third equation, and by doing so, we get 14b plus 78c plus 252d equal to 4,232. And we can also get the equation 15b plus 80c plus 255d equal to 4,395. This is obtainable by subtracting the first equation from the third equation. So with these equations here, what we can do next is take the equation here and multiply both sides by 14. Doing so gives us 14b plus 28c plus 42d, and that gives us a right-hand side of 2282. Now, what we can do next is take this equation that we just obtained here and subtract it from this equation. This leaves us with 50c plus 210d, which is equal to 1950. And we can further simplify this down by dividing both sides by 10, giving us 5c plus 21d equal to 195. C and d clearly have to be non-negative integers. So that means we can have d equal to 0 or 5. And with that, we can have c equal to 39 or 18. So if D is equal to 0 and C is equal to 39, then we have B equal to 163 minus 2 times 39, or 163 minus 78. And that gives us B equal to 85. And then so A would just be 350 minus 85 minus 39 minus 0, which is 226. These four values of A, B, C, and D will all give us S sub 2 equal to A plus 4B plus 9C plus 16D. And adding all that up gives us 226 plus 4 times 85 plus 9 times 39. And we further simplify this down and then add it all up. 226 plus 691, which is 917 as the value of S2. Now let's look at the second case. If D is equal to 5 and C is equal to 18, B would be equal to 163 minus 2 times C minus minus 3 times D, and then that gives us 163 minus 36 minus 15. And then doing the required computation gives us B equal to 112. Now, let's find A. A would just be 350 minus 112 minus 18 minus 5. And then doing all that computation here gives us 350 minus 135, which is 215 for the value of A. And these four values of A, B, C, and D will give us S2 equal to A plus 4B plus 9C plus 16D, which is 215 plus 4 times 112 plus 9 times 18 plus 16 times 5. And that gives us 215 plus 448 plus 162 plus 80. And then when we simplify this further, we get 215 plus 690, and then adding all that up gives us 905. So we have two possible values for the value of S2, 917 and 905. The original problem statement asks us for the minimum possible value for S sub 2. And we see that 905 is the smaller value. So the minimum value for S sub 2 is 905.